Hello, my name is Alexandra Holloway and today I'll be presenting my World of Maths assessment on the mathematical phenomenon. The mathematical phenomenon that I've chosen is a natural phenomenon called symmetry. Symmetry is defined as the quality of being made up of exactly the same parts. These parts can face each other or go round an axis. The term symmetry comes from syn, meaning together, and metron, meaning measuring. For example, here I've drawn this shape of a circle. It's whole together, and using my metron measuring, I've drawn a half down there. So here we're representing the together and the measurement. My target audience of today is grade 3, and in the grade 3 curriculum of the AUS VELS, symmetry is taught through creating symmetry patterns, pictures and shapes, and then identifying symmetry in the environment. So for my activities today, I branch off with creating symmetry, pictures and patterns, so giving the students the basics. And once they've engaged that, being in the 21st century, I've encouraged students to be active and independent learners. I've done an activity on identifying symmetry in the environment, so using real life experiences and getting the children out there to use the concepts they've learned and put it into action. So symmetry, as I've said, is defined of equal parts. In my image here, I have a picture of a symmetric tree. You can see that through the metron measurement down the middle, or the line symmetry, you can see the shapes measure the same on both the same side. So the opposite of symmetry is asymmetry, and this obviously refers to the lack of quality. And you can see in this picture here, I have another tree, but the measurement isn't the same. They're not equivalent parts. So within education settings, there are numerous types of symmetry that you can use, but the most common types that would be in the AUS VELS grade 3 audience would be reflection symmetry, rotational symmetry and point symmetry. So my examples of this is reflection symmetry is exactly what it sounds like, reflective. It could also be called line symmetry or mirror symmetry. In my example here, which will also go on to be an activity, you can see the picture of the lady here. On both sides, she's the same with the measurement down the middle. We've used a portrait on this side, and on this side, when we've cut the picture in half using the metron measurement, we can see here when she's drawn herself, it's exactly the same. This is where the mirror image of the symmetry would also come in, where you could get the students with a pocket mirror to use their face and see on this half, and this half would both be the same. The other type of symmetry is rotational symmetry. So this is when an image is rotated around the central point and you can see it 2 or more times. So the appearance and the occurrence is called order, and it looks the same after rotation. So in my images here, I've got some dumbbells, some triangles, a cross and some stars. You can see here I've had a go at using the triangle, moving it in different shapes, and you can see the rotation of the axis going around, and it still looks the same. The next type of symmetry is point symmetry, and point symmetry is where it has a matching point, same distance and same central point, but it goes in the opposite direction of each other. So an example of this could be the reusable waste sign. You see the symbol is the same, but they're going in different directions, but they have the same central axis. Another example would be this point here using graphing. You can see that there's the line, the axis is the same on both sides, they're the same shapes and the same measurement, but on different sides. So the aim of teaching symmetry in the grade 3 level would be develop an essential knowledge. So to succeed, students would probably need to have a background of understanding in basic shapes and lines such as vertical, horizontal, to apply these skills in the symmetry method. So through learning symmetry, students will learn how to think and reason in logical mathematical terms and ways. So during the symmetry lesson that I have planned, this is my first lesson, which would attack the curriculum of AUS VELS of creating symmetry patterns. And this task here would engage the students in the sense that they're using a picture of themselves, they've got the hands-on picture, taken the photo, and then on the other side they get to include their art, which is for grade 3s, they love art, and that'd be great to incorporate mathematics and art, especially for those students who aren't so maths motivated. And in this picture they would be able to also use a little pocket mirror and see the difference between and there. And then once they've grasped this concept, you'll be able to see, and then you would branch out into identifying symmetry in the environment. And this could be going outside and seeing symmetry in the leaves, the lines down the middle, are they the same on both sides? Looking at Aboriginal art or carvings on rocks, buildings with windows. They're all looking at different types of symmetry and getting students, as now we're in the 21st century, to be active and engage and represent their learning that they're learning in the classroom and visualise it out in real life. So they're building up their mathematical strategies and actually using them. So for children to explore symmetry, they've gained an understanding of basic shapes of lines and understand the first concept. They can create the pictures and the shapes, and then they move on to identify it themselves. So this natural phenomenon is great for getting hands-on experience for the students, and I chose these activities because I felt it would engage the learners. So the use of my exercises would hopefully incorporate the different types of abilities of learning styles of students and also engage them a bit more with, while also using real-world examples. And I've got a reference here from Voldemort, who wrote a piece on symmetry in 1996, and he said, "Symmetry can be seen everywhere. It's a natural and man-made object." And in my presentation today, I hope I've addressed how symmetry can be a natural phenomenon and how students can use it in different types of ways. Thank you.